Hello, everybody, and welcome to our first episode of Slices. So basically, we are on holiday, but we are not leaving you hanging, as Sebastiano mentioned on Twitter a few minutes ago, or it was a couple of days ago. I mean, we never know, right? Because
or maybe it was in the future.
It was in the future. I mean, we will never know. But anyway, this is a series of chats that we are going to have with friends that are very, 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 very expert in domains that we don't know anything about. I don't know anything about. Sebastiano knows everything, so that's okay.
That's not true.
Today we have Erik. Welcome, Erik.
Thank you.
Hello, Erik.
Erik is our in-house resident Bluetooth Deus Ex Machina, basically. Erik, how are you doing today?
I'm good. I'm on vacation, sort of, as much as you can be when you're an independent developer, but yeah.
I heard you're contracting for yourself mostly these days.
Yeah, pretty much. Renovating a house is a different sort of refactoring I'm not used to.
Fair enough. We saw a video the other day on Twitter that you were throwing away a piece of your house.
Yeah, it's interesting. You buy a house and you spend like the first year just throwing stuff away that used to be attached to the house. So that's what I've done mostly since I bought it. It's very interesting. I'm looking forward to putting stuff onto the house soon.
That's at least they don't come with pull requests, so you just throw out the stuff like code. I mean, if only we have that opportunity with code.
There is a sort of a pull request. It's like this building permit that you need to build the extension to the house, which takes forever to get here because reasons. Yeah. So
I thought you were gonna say that you need to ask your wife first.
Oh yeah. Sure.
Sebastiano, don't joke about this. Erik, you can somebody is probably assaulting you, Erik. The door just moved behind you. Anyway,
that was my cat.
Yeah. Oh yeah,
fluffy
definitely
cat.
Assaulting you. Definitely then. Oh, love it. Okay, so today we are talking about Bluetooth, and I know very little about Bluetooth, and what I learned about Bluetooth was from our previous episode that got lost. So I know a bit more. So probably I can. No finger pointing here. So Windows, probably Windows.
Yeah.
Anyway,
or Android Studio. Who knows?
I still have a lot of questions for you, but we will probably stick to the ones that we already expanded on in the first episode because that's the good stuff, and I want more anecdote. So
we start with the big one, which is, Erik, can you please explain to us what are the differences between Bluetooth Classic, Bluetooth Smart, Bluetooth LE, and why we should care, and if we should care?
Yeah, so Bluetooth Classic is actually that's the legacy. It should actually be called Bluetooth Legacy because that's what it is. It's what we're still using mostly when we're using like headphones or Bluetooth connected keyboards and stuff like that. So it's been there for a while. We rarely use it in application development. We can do it. It has some features that we can't do with Bluetooth Smart or Bluetooth Low Energy. But most of these days, application developers use Bluetooth Smart. And when I say Bluetooth Smart, everyone is like, isn't it called Bluetooth Low Energy? That is the same thing. So Bluetooth Low Energy, or BLE, as we sometimes say, is the same thing as Bluetooth Smart. And why is that? Well, they decided that Bluetooth Low Energy was a bad name for marketing purpose, so they created the name Bluetooth Smart because it's smart.
And also, you don't want to imply that the other Bluetooth is not low energy.
No, the other Bluetooth Classic is not smart.
So, but jokes
Does
aside,
it do homework?
Nobody ever says smart. I mean, that's the BLE is the thing, right? I'm the only one that never heard about Bluetooth Smart.
They print Bluetooth Smart on the boxes and stuff like that because they have to. They never print but everyone says Bluetooth Low Energy, and that's what BLE or Bluetooth Low Energy is. It's a version of Bluetooth that consumes significantly less energy. So it can run for much longer on a small battery compared to what it would if it uses Bluetooth Classic. So that's the purpose of it.
But from a use case point of view, they are not the same. I don't
No.
Because I mean these are classic, I assume, right? Because this is a headset or something.
Yeah. So a headset. This depends here. So it's probably using both, and there is an audio version for Bluetooth Low Energy called LE Audio that you can use for headsets and stuff like that as well. But the reason you use Bluetooth Low Energy for application development is because it fits the purpose what we want to do. We want to communicate with peripherals, and we want to use as little energy as possible because a little peripheral, usually a smartwatch or a smart lock or some other device that runs on a battery and sits out somewhere, it has limited power and it needs to be running for days and days. So yeah.
Okay. And so correct me if I'm wrong, but my idea of Bluetooth back in the days when I tried to do something, it was more like you can see Bluetooth as a kind of a serial connection kind of thing where you were actually opening a sort of socket or that you were just pushing data to.
Yeah,
then when it comes to the BLE thing, I'm more like seeing it as a burst, right? I don't imagine it as the thing is always connected, because being always connected for me is draining battery like there is no tomorrow. So is it a good assumption, or I'm just making it up?
That's a good description. So as you say, Bluetooth Classic, you can do streaming with that one, which is you basically can open a socket just like you open a socket to another host, or like a TCP socket or something like that, and you can get an input stream and output stream and read and write to that. That's what Bluetooth Classic allows you to do. That does not work with Bluetooth Low Energy, because Bluetooth Low Energy is a message based. It's short messages. And how short is it? Well, each message can be 20 bytes long at most.
20 bytes, okay.
Yes, and that's the default size. There are ways to increase the size, but we should remember that then both sides need to support that. Both chipsets need to support that. Both sides need to support the correct firmware and such. And 20 bytes is not much, but if you think about they go fairly fast at 1 megabit per second, so you can push some data between there. But this is also the reason why, when you do firmware update of your smartwatch or whatever other BLE peripheral you're working with, it takes a long time.
Yeah,
so
fair enough.
Mm-hmm. 20 bytes at a time. And basically you need to push it over. You need to wait for the confirmation for it having been pushed, and going back and forth and back and forth.
Yeah. So, how is the protocol? How do you imagine? I mean, explain it like I'm 5, and if I have to send a megabyte, no, because that's serious. Because if I have a socket, my idea, okay, I have a socket, I just stream 1 megabyte, I probably stream a checksum of some sort. On the other side, they get a megabyte, they tell me, oh, Ivan, everything is fine, done.
Yeah, exactly.
On a message-based thing, that makes me anxious just thinking about it, because it's okay, oh yeah, I have a megabyte, it's 20 bytes per message. This is going to be like a gazillion packets, and I'm already anxious. So
yeah, you basically have to prepare it in advance. You have to okay, so it's one megabyte I have to transfer. You calculate how many chunks you have to chunk it up in, and then you add a little bit of headers and stuff like that, and the checksum for each package, and you send each package over and you wait for the package to confirm. And then, because this is also a way, there's a part in BLE that's called GATT, G-A-T-T, or generic attribute profile. Again, the abbreviations in Bluetooth is very difficult. My cat is making noises this time. So the GATT is basically the structure of the services that are on the peripheral. So there, at the top you have the GATT, and under there's the services, and each service is basically just a grouping of what is called characteristics, and the characteristics are your data points, or data interface, or I/O ports, or something like this is where you read and write. Now,
okay.
So what you do is you write your value to this characteristic, and then you tell the Bluetooth chips that now transfer this one, and then you get a call back saying, okay, now I wrote it. The other side have received it. You can write the next one now. Then you have to keep doing that one. And on Android, the whole API is callback based. So you can imagine the callback hell you have here. So
Jesus.
Yes.
Okay. I was actually about to ask, do we have support from like a nice API, or do you need to do it manually?
We don't. We have no nice APIs on Android. So there's been two main challenges with Android. The first one being that Android, up until Android 8.0, the Bluetooth stacks and the Bluetooth APIs together were very, very bad.
Android 8.
Yes, Android 8, things got much better. I will go into details there. The callbacks happen on a binder thread. I'm now going into Android deep level OS details, but a binder thread is basically the connection, the IPC connection between two processes. And each side here, so if the calling side, the Bluetooth system in the system server calls your app and and calls a callback on your app. And those two threads in the system server and in your app, they are synchronized. So if you block here, you block on the system server. So what happens if you block it for too long? Well, you get the equivalent of an ANR on the remote side. So that was what could happen on some devices. I would say kind of a lot of devices had that problem. And with Android 8, they improved the API so you could pass a handler to the Bluetooth APIs in Android, so that callbacks happened on a different thread. So you wouldn't, even if you blocked it, you wouldn't crash the remote side. Now, that's a small improvement, made things a little bit better. But that was one of the problems with Bluetooth. So there was a bad Bluetooth stack, and it had a built-in vulnerability that very few developers knew something about.
Okay.
Yeah. So there is a chip from a chipset manufacturer, Texas Instrument, Nordic Semiconductors, Marvell, whatever. There are probably many. And on top of that is their driver, their device driver that communicates with a host operating system. And the Bluetooth stack, when we're talking about that, that's basically what sits on the operating system talking to the chipset. Simplified a little bit, of course, but basically that's where we are. And that. Yes. Yeah. Exactly. So there is most of the BLE peripherals are very simple. They're not a powerful Android device, or well, the Android Wear devices are, but most of the stuff that we app developers work with are custom devices with just basically the BLE chipset on a very thin OS and stuff like that. And it's easy to get that wrong. Because as I described, the characteristics are your data points. This is where you read and write. But sometimes the embedded developer who develops the peripheral, they make a mistake. So they assume that they don't think about concurrency and stuff like that, because they don't have to do that in their world. So if they just have one characteristic both for reading and writing, you can get into race conditions. And I've seen that on several devices, several custom devices, where they only declare one characteristics because you read this one and then you write it later, and then they don't think that, because reading and writing happens locally and then you tell it to transfer. So you don't know what happens if you got it right there. So it doesn't tell. There's no way to get around that. So that's why you should never have a characteristics where you both read and write. You should always separate those two into two characteristics at least.
And this is something that the piece of metal, the hardware part and the firmware part should do. Actually, you have no control on that. I mean, the manufacturer should have.
Yeah, the manufacturer of the peripheral, and hopefully if you're working on a product, there's someone else on your team that does this, write the firmware for this device, and they can do it. If you're unlucky and working on some ready-made firmware on a device and they can't change that one, and they only have one characteristics, well, then you're in trouble.
That's no experience at all.
Yeah.
But how the thing is evolving? Because version 4, version 5,
yeah,
did thing get better with? I mean, I don't know.
So again, on the
is there like a light at the end of the tunnel?
Yeah, things got better, especially with adoptions of the new Android. So they made some major revisions to the BLE APIs in Android 8, thanks to the support that they declared for Bluetooth 5. And from a technical standpoint, the Bluetooth 5 introduces one thing that's important for us app developers. So there's lots of things in Bluetooth 5 that is very nice and stuff. But for app developers, it's a possibility to either increase the throughput or increase the range, or rather, like, you can increase the throughput, which will reduce the range, or you can increase the range, which will reduce the throughput. And it works basically in the fact that when we send a byte on BLE, they are represented by what's called signals or symbols. I think the name was. I can't remember the exact term there, but I think it was symbols. we're talking radio technology here. We're not like talking code anymore. But when we reach these symbols, the more symbols you have, the better error correction you have. The better error correction, the more symbols you have for each byte, the better error correction you have. The better error correction you have will allow you to have a longer range between the two devices without increasing the power consumed. And this is very important. So this is called tweaking the PHY options, PHY, the physical layer options on the Bluetooth chip. You tell the Bluetooth chip, okay, now go to a 2 megabit connection instead, and it switches up and uses less symbols so that it can get a faster throughput. It needs less symbols transmitted, which means it can send that data faster. Exactly. So you can tweak these things. So you can set it to be a 2 megabit, or you can set it to be coded. And coded has a bunch of different values. So if you set it coded to 8 signals or symbols, you get, I think it's 128 kilobits, but you get a much longer range. And this is useful, for instance, when you have a peripheral that's going to communicate with your phone when you're not having the phone on you. One of those examples is like a safety alarm that elderly people would use. They maybe not carrying the phone around all the time, but they still want to be, if they trip or an accident happen or they want to trigger an alarm, they still want to be able to communicate with the device. On the other hand, you want to switch up to 2 megabits when you want to do a firmware update. So what is nice thing about this is you can do it on an active connection. You don't need to disconnect or reconnect.
Oh, nice.
Yeah.
So basically you can have faster connection, but you need to be closer to the phone, for instance. So the thing is like in inversion proportionally, how is it in English? But it's the
it's just one knob, longer range, faster throughput.
Faster. Nice. That simplifies a lot.
Mm-hmm.
Okay, but that's cool. But but you still need to do the manual part of coming up with the protocol to the transmission, right?
I mean, physical. So it's a very raw format. There is no equivalent to HTTP in the BLE world. You send messages, you send a byte array. The Android APIs have some convenience method for writing an integer or a string or something into this byte array, but that's about it. You still have to do all of the things, and it's a callback hell in the default implementation. I'm hoping we will get an Android X library that will wrap this in coroutines so that we can get some niceness out of this. Then it would work. If you ever work with web Bluetooth, you will actually experience a much nicer API. That's what we want. Oh yeah. It is, and so the web Bluetooth implementation, all the functions are promise based, which is the equivalent of suspend functions, so to say. Ish. Yeah. So the Bluetooth Classic has this profiles where it can say, I am a heartbeat sensor, I am headphones, I am a keyboard, etc., etc. And that is that still applies to BLE. A BLE device can have a profile, but since most BLE for application developers when it comes to BLE, this is not applicable. We usually work with custom devices. If there would be a standard, like if it would be a heart rate sensor that we're going to connect to, we don't really need to do much. It's just connect to it. They're ready APIs and stuff available, profiles and stuff how to read for that one. But most of the time when we work with this as application developers, it's a completely custom device. the profiles in the Bluetooth spec, they don't cover everything. I think it was a mistake to have them there from the beginning because you can't predict the future. For instance, there is no Bluetooth profile, or at least there weren't any Bluetooth profile back when I checked for smartwatch. Yeah, the microphone and the headset, and yeah, exactly. Yeah. But fortunately, like I feel like we're moving away from the profiles. So hopefully, most application developers don't have to care about it. So yeah. Yes, there are services and stuff that are predefined, or rather, their identifiers are predefined. So there are everything in the BLE is identified with a UUID, and usually when you read if you get a BLE peripheral and you read the specification for it, you see the short UUID, which is just like the 4 hex characters value. It's basically the rest is predefined, just like one placeholder where there is like 4 hex values that changes. And there are a number of predefined of these services and characteristics, of course. But that doesn't mean that you can't use them for something else, or you can come up with your own, which is the thing. It's just IDs, it's just identifiers. How you communicate them, how you read data is still up to you. Yes, that is true.
So even from a usage developer point of view, so it feels like there is a standard, but there is no standard. I mean, you are more like, okay, this is the piece of metal. You query the GATT for like, oh, okay, there is a tree of possible characteristic, and then you start poking it. I mean, how do you approach something like that? Because I'm trying to imagine, okay, can I reverse engineering the Xiaomi? So please don't sue me. This is just hypothetical. But
that is an important question. So unless they require, they have added some encryption on top or something like that, unless they have done that, it can be difficult. But you can use, like, there are several apps out there. The NRF Connect for mobile is the Nordic Semiconductors app that lets you connect to any BLE peripheral and see the whole tree of services, characteristics, and descriptors. That one is useful. That would be for reversing, and it works with any BLE peripheral basically, unless there is some authentication and bonding and stuff happening that prevents this for some reason, which is usually not the case, because any security is usually added on top in the application layer. So you think of it as how to say, it's not, security is added later. It's not you can't do it like you do with IP communication where you have SSL and stuff like that. Yeah, exactly. Yeah, so and if you encrypt the payload, basically what you do is you encrypt this byte array that you write to each characteristic. So you don't encrypt the communicate. You as application developer, you don't encrypt the communication per se. There is an encryption on the communication, but it's not very strong. It's not so. Yeah.
So I mean, please, no, please.
Yeah, let's take that first. So in the only terminology that I think actually is defined by Bluetooth is, it's bonding. You bond two devices to each other. Basically, you just exchange keys and you say, okay, now I trust this device here. And that's useful because now if you wouldn't have that and another device would come with the same hardware address and you would connect to that one and you would exchange information and you don't know it's the wrong one because so the bonding is exchanging the keys so that you can trust the other part. And the pairing is sometimes called the same. We sometimes call pairing because I think it's in the Android UI it says pair. I think when it pops up, which is funny because the API says bond. So yeah, I know. So that's so I think it's because when you pair, you create a bond. But
of course.
But remember that this comes after you connect it. So for instance, I'm working with one BLE peripheral now where I can't communicate with the device until we have bonded. It won't allow me to discover the services or see anything. So I need to bond before I can start communicate with it. Yes, and that's the part of BLE that came first, actually, when they called beacons, the advertisements. So any BLE peripheral will send out with regular intervals a package saying, this is me, this is my name. And then there's a little protocol there defined that you can put extra data into it. So the BLE peripheral sends out some data, usually a name and some UUIDs. And the UUIDs would probably match whatever services you have on the device, but they don't have to because the advertisement part or the beacon part of BLE is completely separate from the GATT part that we talked about before, but we communicate with it. Beacons are basically just advertisements. Yeah, exactly. Yeah, and there is underneath there is actually a request response thing that happens under the hood. So when you scan for devices and you find one that you're interested in, your phone can send a message to that one, say I'm interested in more data, and then that device will send another advertisement packet with additional data. But that's underneath the hood of the whole thing, but it's still just advertisement packages. And unfortunately, a lot of these BLE peripherals, they don't they send out a name, maybe they send out a unique UUID for the service, but since there is no direct relation between the advertisement packages and the GATT profile with the services and characteristics, they often skip this. They don't include the correct UUIDs that you're interested in. So scanning for devices can sometimes be very, very difficult. But yeah, so most cases, I have to resolve the scanning for the name, which is unfortunate. Well, that's one problem, but the other problem is that the name, what if you have 3 devices of the same?
Yeah. Fair enough. So sounds like fun.
It is very interesting and you learn a lot. And lately also I've been working on the whole the firmware part, the embedded writing the BLE code for the embedded device, which in COBOL, of course, in COBOL. No,
Wow,
in C, in old school C code, and usually this development environment is anything but nice. If you're lucky, you have to use Eclipse. So there are basically 2 major chipset manufacturers. Yeah, there's Texas Instruments and there's Nordic Semiconductors, the later being the more higher quality and nicer experience one. Unfortunately, I have to work with the Texas Instrument right now, which has a very cumbersome development environment. But Yeah, there's I don't envy being a full-time embedded engineer. It's probably fun if you know all the quirks, but I'm just getting started basically, and it's very confusing. A lot of weird documentation and bad documentation.
Luckily, I left that word 10 years ago. But I have still a lot of friends working on that side of very small things running Linux or even not running Linux. They are so small they can't run Linux. So
yeah, none of these run Linux. There's nothing. There's basically just a loop.
Nice.
Yeah.
It's like a while through. It's a while through because it's a real time. That's
Anyone done anything with Arduino will know. Feel familiar here. So
Arduino is basically a loop, like a while through. But it works. I mean, it works.
Yeah, it works.
Nice. So, any more questions? I guess we are done. Yes, a workshop. It's a workshop.
It is. It is.
Oh. Hi, I'm Erik, and I work with Bluetooth. Hi, Erik.
Exactly that. We're starting a support group for all of you here. We're meeting every Tuesday. Yeah. No, it is a challenge, and you can run into a lot of weird things. The only tip I can have for Android developers is if you can keep your minimum SDK to Android 8, 26, right? Or is it? 27, 20, whatever. Android 8.0. If you can have that as your minimum SDK, life will be much easier. Then use all the latest APIs that are available there. I'm gonna update my blog with more information, but yeah. Yes. Literally you can use a main thread handler. It's fine. You just have to get off the binder thread for your call. So that's about it. Thank you.
Well, I liked how we went in a different direction this time because there is so much stuff to talk about, and I love it. I love it.
Yeah. Well, I'm looking forward to when I get time not working on my house. I hope to be able to update my blog series about Bluetooth. I had promised to update it, but things happen. How's happened?
So, thank you. Mm-hmm. Ciao.
Bye.